Howdy folks, W6DKW here. In this episode, we're going to start a 49-to-1 transformer build for an Endfed Halfwave. But we're also going to add a coil at the end so that we can pick up 80 meters and have the antenna a lot shorter. Let's go over the mat and I'll show you what I'm working on. Okay, so this is the transformer. We got a dual core FT240-43. These are two of them taped together, and we already completed our windings. This one right here, the one that's double twisted, that will go to the ground pin, and then this one is the center conductor pin from the coax connector, and then this one on the top will go to the screw right here, which would be the antenna wire. But one of the other things we want to try to do is we're going to put a coil on this. This will be 110 microhenries. And the coil will go about 20 meters out away from the feed point. And then we'll have an additional 2.5 meters or around 8 feet of wire for 80 meter operation. So what we figured out so far is I need roughly 175 turns and a total linear length from one end of the coil to the other of about 10 centimeters. And that should give me roughly 110 microhenries, which is the inductance that we want. So let's pop over the calculator. I'll show you what we figured out here. So on this calculator, it's M0 UKD. That's Mike 0 uniform Kilo Delta, and this website has a calculator that I like using. It has actually several calculators, and so this one we're going to put in the coil diameter right here. You put in the coil length. This is the linear length as it's wound onto the form. So if we pop back over to the bench here, I'll show you again. Let's see. Okay, so linear length is what I mean is from the first winding all the way down to the last winding. And this is a guesstimate you can start with. I'm starting with 10 centimeters or 100 millimeters. So that's basically the idea. Let's go back to the calculator. Okay, so on the calculator, you can see I've already put 175 turns. This will probably be small gauge wire, like 20 gauge, 22 gauge. Probably start with 22 gauge and see if I can hit the mark. You can put in the operation frequency. It usually just tells you what the Q will be for the coil. But in this case, I just want a value of what the coil should be in microhenries. And so if we follow this, it's a 20 millimeter diameter for the pipe form, the PVC pipe, 100 millimeters for the overall length from the first winding to the last winding, and then total number of turns of 175. And we come up with roughly 110, right there, 111.241. And that is close enough. If I'm anywhere in that ballpark, what I can do is take a winding off or add a few windings on. But this will definitely get me right there, and then using an LCR meter, I will figure out the rest. All right, so that's about it for right now. When we come back, I'll get the coil pre-built and most of the antenna mounted, or sorry, most of the transformer mounted into the case, the 49-to-1 transformer, and then we'll start figuring out lengths of wire after that. All right. Well, All right, well, it's been a few days later, and we got the coil pre-built. I'll show it to you right here. Let's see, on the desk. So this is the coil with the heat shrink over the top of the windings. Um, I drilled a little hole on either end to pass the wire through, as you can see here. Um, and during construction, I took a single picture to show you what's going on. So let's show you what that looks like. All right. So as you can see here, there's a couple pieces of Kapton tape used to hold the coils in place. This is roughly 170 turns of 22 gauge magnet wire. So I actually ran out of room. I hit maybe about 150 turns and then doubled back on itself, going in the same direction clockwise around the form. And I stopped roughly here. So the total inductance is 113 microhenries, which is perfectly fine. Plus or minus 1 or 2 microhenries isn't going to be a big deal for what this thing actually does. As I mentioned before, this goes at the far end of the Endfed Halfwave, and it's essentially like a trap, and it's a trap for 40 and above. So 40 meter band and higher frequencies. We'll see this as a dead end. So if this over here is the area for the actual winding or the antenna wire, just pretend there's 66 feet of wire here. When it hits this trap, it's like the end of the wire for 40 meters and above. The only thing that will go through the trap is the 80 meter. And on this end, all we need is another 7 feet to make the entire antenna length equivalent electrically to an 80 meter antenna. So this trap becomes mostly transparent. It becomes an electrical length of 40 feet or 30 feet or whatever, plus the 66 feet at the other end and the 7 or 10 feet on the tail end. Then your total length is roughly in the 80 meter band. So for tuning, we'll have to tune this shorter 6 foot section. I call it 6 foot section, but it's probably going to be like anyways between 6 and 8. We'll just have to see. For tuning 40 meters and above, you tune this part. You trim the 66 foot long section. So that's pretty much it for the trap for 80 meters. That will allow me to operate at 80 and have the antenna physically shorter because my property won't allow for a full 80-meter long antenna. So that's why we're doing this. And then now we'll have to show you some of the transformer construction. So we'll get to that right now. All right, we're back and we got the transformer constructed. So let's hop over, take a look at that. Okay, so what we have here is the 49-to-1 coil transformer installed in the case, tie wrap to secure it. The lead that's for the antenna goes up to this nut here that I'll probably eventually swap out for a wing nut instead. And then we have a ground right here. And the center conductor is soldered to the center pin of the SO239. And the 100 puff capacitor is placed from the center pin to ground. And maybe you can see a little bit better. I'll bring it a little closer to see if it focuses. Okay, so one leg of the cap is on the center pin. The other leg is on the ground. This ground goes to the nut, and basically it's the same ground as the rest of the coax braid. It's the outside connection here. Let it focus again. So that, along with the 2 turns for the primary, every time the wire goes through the center, that's a turn. So there's 1, 2 turns for primary. And then the secondary, since this is wired as an auto transformer, you count these 2 as well. So it's 1, 2, 3, 4, 5, 6. This is 7, 8, 9, 10, 11, 12, 13, 14. So it's 2 turns on primary, 14 turns on the secondary, and then just connect it to the antenna terminal. So what we're going to do is we're going to mount this on the side of my garage at about 6 feet. And then we're going to string some wire about 66 feet. Then it's going to hit this 110 microhenry coil. And then we're going to have about another 6 feet or 7 feet. Yeah, put together a little quick drawing. So let's see if we can make sense of this a little bit better. Hopefully that comes through. Center it up a little bit better. There we go. It'll focus. I guess that's okay. All right, so here's the 49-to-1 transformer mounted about 6 feet up on the side of my garage or carport. The coax from the transmitter comes in and feeds into the SO239. On the antenna connector, we got 67 feet of wire, and we hit the 110 microhenry coil. So this section here is what's resonant on 40, 20, and 10. And this section here is the part that gives us resonance on 80 meter. So as I said before, all the frequencies 80 meters and lower, to see this as a straight wire, and it makes the entire length electrically resonant on 80 meters. And we have a little insulator, either a dog bone insulator or what they call the egg insulator that kind of look like a black plastic egg with fins on it. I use either one. Most of the time I like using the dog bone type insulators, which you can get on Amazon. And then some polycord to hang it up in a tree. And so our elevation here at this point will probably be about 28, 30 feet. The elevation down at this end is about 6 feet. Now, as far as counterpoise goes, I suggest start with 12 feet of a counterpoise wire connected to the ground pin, and just let that drape down, or whatever's laying on the ground, you can actually just bury it. That's what I usually do. Usually 6 feet, since this is 6 feet high, 6 feet of it will be just going straight down to the ground. And then the other 6 feet, I just bury it into the ground. And then what you want to do is 12 feet from the transformer, use an RF choke. So what we're saying here is go backwards from this point here where the feed comes into the transformer, go back about 12 feet. It can be 12 or 14 feet. I tend to use somewhere between there. 12 feet. You're going to want to install somewhere around where my finger is a RF choke capable of the power rating that you're running. So 500 watt choke would probably be fine for most operations. You could go up to 1,000 watt choke, but definitely install that. And by choke, I mean you could do the coax wrapping around a toroid type choke. That works perfectly fine. You could just do an air choke, which is just several turns of the coax bundled together with tie wrap, so that it becomes essentially an air choke. There's no core except for air. So you can do, I think, 7 turns of um, say RG58 or several turns of RG8 tied together with tie wrap in a circle or coil. That works. Most of the time, I will buy a off-the-shelf RF choke rated at 500 watts and install it right here. So anyway, the total length of this assembly is 75 feet. That's from the transformer all the way up through to the insulator. And that's definitely doable on my property. And I mentioned before, the full 80-meter half wave length of like 130 something feet. I don't have enough space on my property to do that. That's why we're going this route. All right. I think that kind of does it for right now. When we come back in part two, I'm going to do this in 2 parts. I will have partially installed the transformer onto the side of the garage and strung some antenna wire out, and probably made some initial measurements of the resonance using a nano VNA, and see how we're doing on the 40-meter band, how we're doing on 80-meter band. And then we'll make some adjustments on camera, start measuring again, and see if we can dial it all in after it's up in the air. So I'll see you next time. Bye.